Hello everyone, my name is Dan the Tutor. This is a clip from one of my weekly group tutoring sessions at the University of Delaware for Math 221. If you have any questions, please leave them in the comments below. Thank you and enjoy. Now we're going to move on to definite integrals. We can't forget about definite integrals because they will definitely be showing up. And they're not too bad. They're not too bad. And we've talked about them before together, or at least we did 2 weeks ago, which means you all forget for some reason, which is okay. So let's deal with this first problem here. I have the integral from -2 to 0 of x dx. Right away you notice the big difference between definite and indefinite integrals. Definite integrals have bounds, indefinite integrals do not. Luckily the process stays exactly the same for most of it. In other words, if I ask you to take the integral of x dx, you should all know this integral because it's an easy power rule antiderivative. This is x to the first power, which means the integral is x squared over 2. I added 1 to the 1 plus 1 is 2, divide by 2, and then plus c, right? No plus c for definite integrals. Whenever you have bounds, instead I'm going to draw a long vertical bar like this, up top 0, on the bottom -2. I'm actually going to be plugging in 0 and -2 in for x here and subtracting the two quantities. So what I get is 0 squared over 2 minus -2 squared over 2. So this is going to equal 0 minus -2 squared is now positive 4 divided by 2. I'm going to get a final answer of -2. Okay? Any questions? This is the answer. I have a question, and if you meet with me one-on-one, you can't answer this question. But anyone who doesn't, you are allowed. What does this answer -2 mean in the context of real life?
The area under the curve.
Correct. Great. Who said that? Just give me a first name.
I was Madeline.
Madeline. Tell me, did your professor tell you this?
No, I watched your last week's video this morning.
Great.
Or 2 weeks ago video.
I love to hear that I'm doing a better job than your professors. That always warms my heart. Okay. So, oh yeah, by the way, yes, I upload all of these to YouTube, and you can check out the ones from last week, as well as if you ever want to take physics for whatever reason, those videos are up there as well. Okay, so we're going to go from -2 to 0. These are the x bounds, by the way, and the area is the area in between the function between the points x equals -2 and 0. This is literally what the integral means. The integral from -2 to 0 of x dx. Why is it this line, by the way? Well, because this is the line y equals x. That's the function. And what I'm saying is the black shaded area is equal to the integral from -2 to 0 of x dx, and that area just happens to be -2. So just to quick prove that this is right, well, this is just a triangle, right? And hopefully we all know the area of a triangle. Area equals 1/2 base times height. So the base, that's going to be 2. The height, that's going to be -2. The height is -2 because, well, that point right there is -2 comma -2 because the line's y equals x. So I have a height of -2. I have a length of 2. We're going to get an area of 1/2 times 2 times -2. That area is equal to -2, which is exactly what we got when we did using the integral. Any questions? So that's it for the first one. Obviously, you can't always use definite. You can't always use area of geometric shapes. You can't always use triangles. You can't always use rectangles. Sometimes you need to do the definite integral, and let's look at some examples of that. Number 2, the integral from 1 to 4 of the quantity 2x minus 6x squared dx. Question. Well, I want you to think about this in your heads. You don't have to call it out. Is this a U substitution problem? I'll give you a few seconds to think about it. Yes or no? Okay, time's up. Is this a product rule, chain rule, or quotient rule? The answer is no. As a matter of fact, if we wanted to, we could split this up into two integrals. Integral of 2x minus integral of 6x squared. Technically, you need dx here on both, and you need the bounds on both. So this is just going to be two power rules, just like we've seen all day. The integral of 2x is going to be, well, the 2 is a coefficient, times this is x to the first. So I add 1 to the power of 1, like x 1 plus 1. So I get x squared divided by 2. That's the left term. And then for the right term, minus, let's see, 6 times integral of x squared. That would be x to the 2 plus 1, which is 3, divided by 3. There we go. And then again, no plus c. Instead, I'm going to put this all in parentheses for notation purposes, and then a long vertical bar from 4 to 1. I now need to plug in 4 and then subtract when I plug in 1. Before I do that, remember when I said earlier about simplifying? Simplifying does, even though it's not necessary a lot of the time, simplifying is going to make your life a lot easier, especially for definite integrals. Why? Look at this. 2 cancels right here. 6 will cancel with the 3, leaving you with the 2 in the numerator there. In other words, this is easy. This is x squared minus 2x cubed evaluated from 4 to 1. That's actually how you read that, by the way. The long bar reads evaluated from 4 to 1. So now I'm going to plug in 4 first. So 4 squared minus 2 times 4 cubed. That'll be fun. And then that's it for the left one. Minus quantity 1 squared minus 2 times 1 cubed. That's not so bad. Close parenthesis. So this is going to equal 4 squared is 16 minus 2 times 4 cubed. As we all know, 4 cubed is 64. 64 times 2 is 128. And then minus quantity 1 squared is 1 minus 2 times 1 cubed is actually just 2. That's not bad at all. So 16 minus 128. Gosh, I hate mental subtraction. Negative 112. Yeah. Negative 112 minus negative 1, so really plus 1. We'll get a final answer of negative 111. Did I mess that up? I don't think I did. Okay. We'll assume I'm right, as always. Great. Okay, everyone ready for the next one? Any questions? Okay. Number 3. I have the integral from negative 4 to positive 4 of, in the numerator, e to the 2x, denominator, 2 plus e to the 2x, dx. This is a very hard problem. Okay, so again, I'm going to call on a member of the audience. You can just call out. What will my u be for the u substitution? Well, someone has to say... Go ahead.
2x. Is it 2x?
Okay, I'm not going to tell you whether you're right or wrong because, well, I'm not going to be there on test day. U equals 2x. Let's try it. Du dx, the derivative, is equal to 2, well, just 2. Then du equals 2 dx. And now I'm going to say du divided by 2 equals dx. Everyone good so far? Great. So this is equal to the integral from negative 4 to positive 4. In the numerator, I have e to the u. In the denominator, I now have 2 plus e to the u. And then dx just got replaced with du divided by 2. Notice, nothing canceled, but that's not a problem as long as... Do I have any x's here? No, I don't have any x's. So I'm good so far. But I do have one thing to say. Well, I mean, first I'll write this 2 out in front. So the 2 is a coefficient. 1/2 integral negative 4 to positive 4 of e to the u over 2 plus e to the u du. Now the next thing I want to say is, do we know this integral? So I'll tell you this. To whoever said u equals 2x, that's not wrong. Like that's one thing that I'm going to say it's an optional step, but we need to do one more thing. We are going to need another u substitution. Can I have another volunteer to tell me what the u substitution should be now? Okay, I'll just tell you guys. This is not easy, by the way. The u, which technically I can't use u anymore because I just used u, so I need a new variable. I'll call it v. V is equal to 2 plus e to the u. Now, I'm assuming at least one of you have a question. Where did v come from? Would anyone like to ask that question? You don't have to. If you understand it, then you don't have to ask. But does anyone have that question? Okay. I'm going to keep going. But I think this is going to get confusing because most people hate the double... It's called a double u substitution, but we ran out of u, so now it's called a v substitution. Whatever. But now the process is still the same. I'm going to find dv du, solve for du, so I can plug it in right there into du. That's the strategy. So what's the derivative of 2 plus e to the u? The derivative of 2 is 0. Derivative of e to the u is just e to the u. Great. Again, I'm solving for du, so I'm going to multiply both sides by du. I get dv equals e to the u du, and then divide by e to the u. dv divided by e to the u equals du. Is anyone confused yet? You should be. So
I have just like a question. Oh, sorry.
Go for
I
it.
just have like a question.
Yeah.
So like we didn't go over this in class. Do you think that this could show up on our quiz even if our professor like doesn't talk about it?
Yeah, so I want to say the answer is it's a possibility only because this problem right here showed up on your homework. Am I wrong? Not this exact problem, but like something similar to it?
I didn't finish the homework that's due tomorrow yet, so I'm not sure if it did.
Okay, I'll tell you, I saw a question just like this.
Okay.
And so for that reason, which by the way, if you want to, your original u can be 2 plus e to the 2x. That's actually like a lot easier, and it would get the job done. So in hindsight, they should have just not asked the audience for this one because this was hard. But hey, I'm trying to become the best of all time, which means right now I'm not yet the best of all time tutor, but we're getting there. Any other questions? Okay, I'm going to continue. And yes, this is confusing, but there's other problems where you need a double u substitution where you use v, so it's not a bad skill to have. Hopefully you never have to use it. You know what I mean? But it's good to know. I'm plugging in dv divided by e to the u for du. Let's see where we're at. 1/2 integral -4 to +4 of, in the numerator I have e to the u still. Denominator got replaced with v because I said v was equal to 2 plus e to the u. And then du just got replaced with du divided by e to the u. This is actually really good. The e to the u's cancel, and all we have left right now, I'm sorry, that's not du, that's dv. Yeah, this is very confusing, I know. So this is equal to 1/2 integral -4 to +4 of 1 over v dv. Hopefully you know this integral because it's the natural log. It's 1/2 natural log absolute value of v evaluated from 4 to -4. Now, real quick, we need to before we plug in here, before we do this problem, before we evaluate 4 and the -4, we do need to plug back in for u and then again for x, which is very annoying, I know. But it's going to be 1/2 natural log absolute value. V was equal to 2 plus e to the u. So 2 plus e to the u evaluated from 4 to -4. And again, I need to plug in for x as well. X was, we said 2x. So 1/2 natural log absolute value of 2 plus e to the 2x power, close absolute value sign, evaluated from 4 to -4. This is just a monster of a problem. And I'm probably not even going to, this is not going to be a pretty answer, I'll just tell you that right now. But we'll get a final answer of 1/2 natural log of the absolute value of 2 plus e to the, well, 2 times 4 is 8, so 8th power. We can't simplify that. And then minus 1/2 natural log absolute value of 2 plus e to the 2 times -4 is -8. This is about as simplified as we can get, actually, so I'm fine with this. Any questions on this one? This was just not a good problem, in my opinion. Don't forget to like and subscribe. If you want me to start doing free weekly group sessions at your university, please post in the comments below or email me at dan@danthetutor.com. Thanks, everyone. Bye-bye.